discussing Modbus touchscreen PLC programming. We'll start with a very brief introduction, go over the touchscreen PLCs, then we will do a live demonstration showing you how to create a project with HMIWorks software, including using buttons, widgets, displaying temperature, and creating multiple pages. We'll also show you how to read and write from the touchscreen controller's memory. If you have any questions at any time, please enter them into the chat box. I'm Maria Limoni, Sales Manager here at ICP DAS USA, and I have Robert from our Technical Support Department with me. ICP DAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP DAS USA was launched in 2001 to support the North and South American markets. We have over 100 R&D engineers and work closely with them to support you. For any large projects you're working on, we may be able to provide you with free programming and systems integration services. Please contact our sales department for details. Touchscreen PLCs are being used in many different kinds of applications across different industries, including access entry systems for building automation. They're often used with SCADA systems and databases for overall system status. Users have different codes for entry to hotels, offices, and restricted areas. Touchpads are used for displaying classroom information in schools, patient information in hospitals, system status in factories, and as keypad remotes for machines and interfacing with greenhouse and irrigation systems. Touchscreen PLCs combine an HMI interface and a programmable controller all in one unit. They can run one program and have a touchscreen interface on board. They're programmable in C language and ladder logic. You can make different pages inside of the unit, and each different page can be programmed in a different kind of language. They come with free, easy-to-use HMIWorks development software for creating ladder logic and C language programs. They're widely used as keypad remotes for Modbus devices and are available in 2.8, 3.5, 4.3, and 7-inch screen configurations. They work with remote I/O and devices. They can be mounted on a wall or in an enclosure box. They have real-time clocks, support brightness up to 500 candela, and start at $199. They support ASCII, Modbus RTU, and Modbus TCP communication for interfacing with different devices. You can use a USB to serial or Ethernet to serial converter for uploading programs. Some come with the USB port. The 2.8-inch version is powered over Ethernet, the one with an Ethernet port, TPD 283. The power input for the TPD series is 10 to 30 VDC. The TPD 432F has a flange mount. So as you can see in this selection guide here, there's different kinds of COM ports available with different units. The VPD series come with 3.5 and 4.3-inch screens. They have a power input of 12 to 48 VDC. You can put an internal I/O board inside. They also have a real-time clock for scheduling operations. They're IP65 front panel mount, so if you mount them properly in a panel, you can spray at them with water jets. They also have optional rubber keypads. They can be mounted on a wall or in an enclosure box. The VPD series have the DIN rail mount on the back. The HMIWorks development environment is a drag and drop, input text, point and click kind of development environment. We provide many widgets for using shapes, buttons, text labels, and timer objects in your programs. We provide image libraries, and it's easy to add Modbus devices for interfacing with different channels and registers. You can also make your own function blocks, and you can input your own images. This is the HMIWorks development environment workspace. In the center here, you can see that there's a frame design space. Whatever you put there is going to be what your actual screens on your device will look like. If you double-click any object that you put on the screen, it takes you to the programming page. You can use ladder logic and C language in the same project. The Inspector and Libraries tab over here on the right is where you can set attributes like the background or text color, and you can also specify the font size. There's also a results window at the bottom where you can see output and error information. There's a rotary switch on the back of the units. When you download a program from HMIWorks to the touchscreen PLC, you plug in your USB port or make sure you're connected to the COM port depending on which controller you have. Then you move the rotary switch to the 9 position. Then the touchpad will reset. Then you select Run on the HMIWorks software, or you can hit F9 and you download the program. Then you move the rotary switch to 0. The touchpad will reset and the program will be fully loaded into the touchscreen PLC. The Ladder Logic Designer is a standard development environment with left, right, and parallel contacts, coils, and function blocks. You can use free software like Modbus Pol and Modbus Slave Simulator to simulate a master in your application, or to simulate up to 32 slave devices for testing and debugging applications. If you want to use a Modbus touchscreen PLC with devices that communicate over BACnet, Ethernet IP, HART, J1939, or other protocols, we do provide a wide variety of easy-to-use protocol converters. Now I'm going to transfer over to Robert, who's going to be giving you programming training with HMIWorks.
Okay, this is the TPD 433. I'm going to show you how to create a simple project for it. And let's see, the project shown on the web page right here will be one of the sample programs, which I'll show you in just a second. Let me get HMIWorks open. This is HMIWorks. This is the development software for use for our TPD and BPD series. Currently, I believe we're on version 2.0907. Let's see, this is the current version of HMIWorks software. With HMIWorks, you design touchscreen programs, or I guess a HMI, which you can create ladder logic or C programming to run an operation or perform I/O operations. Within HMIWorks, let's see, a lot of the development is using the drawing tools, widgets, and system tools, which I'll show you in a second. Let's see, right here, this is our toolbox tab. This is where, all the widgets and drawing and system tools are shown. The workspace right here, this is where you have your file manager and you create your tags, device connections, and ladder program. If you're going to be doing C programming, you would do something like this, where you would have a timer widget associated with the main page, but we'll go over that in a few minutes as well. Let's see, this is the HMIWorks demo program, which we normally send out with a lot of our touchpads. This is actually a true operational demo that we've used in our factory for controlling air conditioning, the lighting, and scheduling for a theater operation. And notice that it shows temperature in the right-hand corner. I'm going to show you the basics, what's behind the HMIWorks project. Let's see, most of this is just a nice background picture with a few hotspot widgets, which we'll go over in a few minutes, and a slider widget and a label widget for just showing the temperature. But let's see, let's put this back, and let's see, we'll show you, let's see, line it up, but it will look something like that, where there's an imaginary button right here, right here, right here, right here, and right here, which will perform actions. There's a hidden label widget right here next to the letter C to display the temperature. And there's a slider widget right here, which, used in conjunction with the background image, shows the temperature of the theater in, visually, and over here shows numerically. We have a few other pages here that are very similar. Nice background picture, a few library images, and you can create your own library images as well, and your own background images to make a nice presentation. Let's see. Here's another screen. Let's see. This is to control the air conditioning. Let's see. Here's a few other screens. This is a time clock. Let's see. Most touchpads and BPDs have built-in real-time clocks. You can create a clock within your HMI and display the time and date. Let's see, this is for setting the time and for setting the date. Okay, let's see, when you create your project, let's see, you would normally go to File, New, and let's see, let's just do Yes here, and you would select your touchpad type. You would name your project here, and then you would select your orientation of your project, whether you want it to show up in landscape or portrait mode. And we also have available portrait flip and landscape flip. You set the default programming type for each individual screen here, whether it be ladder or C, and you would normally click OK to enter your project. But I want to go back to this project right here. Within this project right here, I want to show you the structure. Let's see. Okay, first of all, within the workspace is your file. This is the program which will be referenced for the whole project. This is the project name demo room underscore TPD 430. This right here in the under program is your ladder programs. Let me just open this as a sample. This ladder logic right here just simply creates let's see, like a scrolling screen, or let's see, every 10 seconds, or actually, I'm sorry, every 180 milliseconds, the screen changes to the next frame. Okay, or actually changes back to the main frame. Let me close this back up. So again, these are where you create your ladder logic if you're doing ladder programming. The touchpads, for the most part, supports DCON protocol, Modbus TCP, and Modbus RTU protocols. To create your device connections, you click on the word connection, right-click, do new connection, you name the connection, then you select your interface. COM1 and 2 are traditionally RS-232 and RS-485 if they're available on the specific touchpad, and there's also Ethernet on some touchpads as well. So you need to be sure to order your specific touchpad or VPD series based on what protocol you're communicating with and what type of COM ports you need. For baud rate, or for, I'm sorry, serial connections, you set your baud rate, data bits, parity, and stop bit options here. Then you click OK to create your connection. This right here is a connection. Pretty much the connection name is called D-Room. Uses COM1, which is RS-485 in this case, and has communicates at 9600 baud, 8 data bits, no parity, and 1 stop bit. Let's see, once you create your connection, you can create your device and virtual tags. Device tags are true I/O tags for like our M7000, ET7000, and other generic Modbus protocol devices, whether it be one of ours or a third-party one. You can create your connection right here. So you would simply right-click on device, select the role of the touchpad. The touchpad can be, depending on which COM port you use, for serial ports, a Modbus RTU master, a Modbus RTU slave, or a DCON master, which uses our i7000 module. For Ethernet versions, it can be a Modbus TCP master or a Modbus TCP slave in addition. And let's see, right here you select which device series you're going to be using. What these do are these make it easy so you don't need to type in the number of different I/O types and number of channels. But let's see, let me just show you a quick example. For M7000 series, we have pre-selected models here with various configurations. For instance, our M7017 is analog input modules, so we'll auto fill in the number of tags right here. So for instance, starting address is 0, and there's 8 channels, so channels 0 through 7 are what you call created automatically. If you have a third-party device, you simply select user defined, and you can go to edit and type in the number of each type of channel you have, the start address, and the count. And a similar display will be shown here where it'll list your channels here, and it'll create it under the device tags. Let me just cancel this. And I'll show you the actual tags in the project. So this actual project uses i7065, which has uh, 5 digital outputs and 4 digital inputs per module. There's various modules in the operation for controlling the lights and the theater air conditioning and time features. So for instance, like each DO channel right here just corresponds with like a relay output, and the digital inputs are probably push buttons or some other type of means for turning something on or turning something off. Let's see, so once you create your device tags, you can use them in ladder logic. You also have the option to create virtual tags. Virtual tags are just like either memory tags, numeric values for creating like mathematical operations, like for instance, if you wanted to convert the temperature from degrees C to degrees Fahrenheit, your device will have a raw value in degrees C, then you perform a mathematical operation, use a virtual tag for the result, and you could display your temperature value in Fahrenheit. Let's see, within the ladder logic program, we offer various coils, function blocks, and fuses for showing the different operations. So for instance, when you want to create your ladder rung, you just select one of these and it'll create your basic rung. Let's see, if you want to add a function block, you just simply click right here. You double click on the function block to choose the function block which you'd like to use. We have AND and OR operation for logic, greater than or equal to type operations for comparing analog values or integer values. The assign function block I use quite often for setting a value or setting a flag. In range and out of range are used for, say for instance, very similar to PID, where you want to have a temperature within, or maybe the temperature of the room between 70 and 80 degrees. So you just put a maximum and minimum, and as long as the temperature is within that range, a digital value will be in the off position, and when it ventures out of the range, it'll turn to the on position, and vice versa for the out of range. The mathematical function blocks, we have add, subtract, multiply, divide, increment, decrement, modulus, which is like the remainder of a division, scaling. With the scaling, we offer both 16-bit scaling and 32-bit scaling. The invert 0 and 1 pretty much just toggles digital inputs on and off based on an operation in your ladder logic. Convert, this one just pretty much, this one right here, C to F, converts the temperature from Celsius to Fahrenheit. Most of our modules put out raw values in Celsius, so this is a very useful function block if you want to display your temperature in degrees Fahrenheit. We have a count up, count down, some timer widgets, or function blocks rather. In our system function blocks, we have the beep function, touch beep, where you can control the on-off state of the beeps. You can get and set the real-time clock. There's a backlight control for making the screen brighter or dimmer. And let's see, we also have a user-defined where there's a few additional ones that are pre-created, but there's also a way that you can create your own function blocks if there's certain operations which you perform quite often, or if you need help in creating a function block, we can also assist you with that. The go-to frame is a very useful one if you want to create like a hotspot to create a page change. If you need to do number conversions, there's a few operations here: word to float, float to word, word to double word. What this does is creates bigger numbers out of 2 Modbus registers, and if you need to convert them back, you can do that and pass it out of the COM port. For the VPD, there's some tactile buttons on the front. We call it panel keys, I guess. Get panel key reads the status of the panel keys, and show panel LED shows the status of these buttons based on the buttons. They have a background LED. For our IR210, we just had an assign function. There's function blocks you have that you can create, and you could also add additional ones that we have. Let's see. So for the ladder logic, you simply create your coils and create your function blocks. And let's see, let me just give you a quick example. So for AND operation, if we wanted to do an AND operation, if say digital inputs 1 and digital inputs 2 were true, then it would turn on a digital output as an example. Just delete that portion by pressing the delete key. So if you need an AND operation for performing an operation, you can do something like that. Okay, once you've created your ladder program, you just click Save and Close, but I don't want to save this, so I'm just going to click Exit. And let's see, let's do No. Okay, now for creating the widgets, let's go over them briefly. So within the toolbox, we have 3 different sections. We have Drawing, a Widget section, and a System section. Let me just go over quickly. Let's just use this page. Let's see, the arrow is just used for simply selecting different objects. The rectangle, drag and drop, and draw a rectangle. You can edit the properties of the rectangle right here on the right side in our inspector. What you could do is select different background colors, let's see, and different brush types. And see, for certain objects, you can also do other operations rather. I'll show you in a few minutes. For the ellipse, you can also draw circles in the ellipses. One trick is, let's see, it's a control button, which you can use to create perfect circles. You hold that down and resize it to create perfect circles. For text, this is very useful too. You just drag and click on that, create a text box right here. Type your text right here, like say, hello. And then you can also click on it again to edit it, and we'll just change the font style. So you click over here on font, and you edit the properties. You can make it bold, and you could change the size to maybe 20, and make it bigger. And you can reposition it by just dragging and dropping. If you want to change the font color, you just, where is it? Font color, you do over here. You go to color. You could change it to, let's change it to navy. And now you have a blue hello. Okay, and you can also use these other properties in the inspector for alignment. Like notice the top and the width, there's left, and there's height. The height and the width are, pretty straightforward. As you make the object wider and stretch it, actually, let's do this. I guess this one's not editable like that, but well, let's do the square actually, or a rectangle. Come on. Okay. So if we were to do this, you'll notice that the height and width changes as I move this. And if you want to adjust the position of the object, you can just select it, get that. Oh, there we go. Then I want to look for those 4 arrows. Where to go? Ah, come on. Do it. Well, you can reposition it if you click on it, right? The picture box, this is used in C programming. Essentially, if you want to toggle between images, you can create a picture box, reference the picture object, and display your pictures in that specific box. The line drawing tool is pretty much self-explanatory. You draw lines of various lengths and thicknesses. Under the widgets, these are what you use for most of your I/O operations. Again, we have the arrow widget, the text push button, which I'll show you an example of in a minute, the slider widget, which is used for controlling analog values and for displaying values like that temperature display on the main screen of this project. The bit button, I'll show you an example of that in a few minutes too. The hotspot, which was used in this frame right here. Again, it's really just a picture of the background, but you touch a certain portion of the screen and it acts like a button. The checkbox widget is used for maintaining operations. Say, for instance, you have a button. When you press it, you want something to turn on and stay on. And let's see, if you push it again, it turns off and stays off. It's some of our other buttons, the push button, text push button, and bit button, those are momentary buttons, so as long as you hold the button down, the operation will be on, and when you release it, it'll turn to the off state. The label widget, this is used for numerically displaying analog values. So for instance, like right here with the C, this right here is a label widget where it just numerically displays like 25 degrees, if it's 25 degrees read by the analog input. And the radio button is a radio button. It's used for selecting, say, one of 3 different objects, and the one radio button will stay lit if condition 1, the second radio button if condition 2, and so on and so forth. Under the system widget, the timer widget is mainly used for C programming, or almost strictly used for C programming. What you do is you, again, create a timer, drag it over here, and you double-click on it. You can set the interval of operation which you want your C program to run, and every 1 second, this is in milliseconds, the operations within your timer widget will run if this were a C program. Since this is ladder, there's no operation here. But if you do C again, that's where you do your program. The paint box is also used with C. This is what you call used for reference when you create pictures. The object list, this is used in conjunction with the checkbox very often. For instance, we did a clock application fairly recently where you create an object list. I'll show you an example in a few minutes as well. But essentially, you create an object list, you select a 0 condition, a 1 condition, a 2 condition, and a 3 condition. So it's a 0. When it's a 0, it'll display this picture. When the value is a 1, it'll display this value. So you can use this in conjunction with virtual tags to create multiple images for your display. Okay, let me just go back here. With this screen, I created a bit button, a text push button, and this right here is using our checkbox widget. The difference right here, with the bit button, it's got a 3D effect, and when you press it, it has like a grayed out background color. The text push button has, again, text right here that'll show, but you also have the option to make a fill color. So when the button is pushed, there will be a color change. With the checkbox widget, let me just create one as an example, checkbox. So we'll draw a square, and then we'll create an object list right here. This is object list 229. So we will come here and checkbox, do reference object, checkbox 229. Now right now it's just a blank square, but let's double click here and select from our library. Let's see, let's go to buttons. And notice the selected object shows down here. We can select 2 buttons, this one and this one. So when the logic in your operation or actual input associated with that button is in a 0 position, which is shown over here, this picture will be displayed, and this picture will be displayed when it's a 1. So we'll click OK, and notice that instead of a blank box, we have the picture. You can resize it, reposition it, and adjust it to size to fit your application and position it. Okay, let's see. To create additional frames or pages within HMIWorks, you simply go up here to Layout and do New Frame. Currently it says maximum frame 10, but you create a new frame. You select Ladder or C program. For this one, I'll do Ladder. And notice a frame 11 and a blank page came over here. Let's see, within the library built into HMIWorks, we have quite a few different categories. You can also add additional pictures. They usually show up here in the pictures. To do that, you go under File and Import Images Library. Then you use the Select button to navigate through your PC to select the corresponding JPEG or bitmap file that you want to import. Here we support GIF, JPEG, bitmap, and a few other formats. There is no transparency within HMIWorks, so you can't create objects which have transparency, but you can what do you call it, import files from like Microsoft Paint or what's that called, or any painting or drawing application which is out there. You just save it in the same format. Let's see, anything else? Does anyone have any questions? If you do have questions, please type in the chat box, and I'll be happy to answer it. Let's see. Oh, and actually the only other thing I could think of is at the very top, once you're done with your project, you can click Build and Render. And what that'll do is check the program for errors, and if there are errors in the program, they'll show up down here, and you'll be able to fix and correct them. Then when you want to download TouchPad, you just click Run, Build, and Download. Download being the key to sending it to the TouchPad. Okay, if anyone has any questions, please type in the chat box.
Dawn is asking, can any type of graphing function be displayed?
Graphing would not be something the touchpad would be used for unless you were able to do a 2D when using like a slider widget. For graphing, that requires animation, which the touchpad is not designed for.
We do provide a different controller, a touchscreen controller that does support the graphing function. It comes with Indusoft SCADA software runtime license, so if you get the development license or the development and runtime package for a PC, then you'd be able to develop graphing type of applications for controller like a VP-23W9 or VP-25W9. We could send you
Yes,
information on those after the training, so you'll
those are
all get an
Windows
email.
CE
You'll all get an email
devices.
later today. Go ahead, Robert.
I was just saying, those are Windows CE devices. Those you do not use HMIWorks to develop the project. Like Maria said, Indusoft is a separate software package which has much more abilities to do animation and graphics and data logging.
David is asking, what is the function of IR210?
IR210 is, how do I say, an IR blaster. So for instance, if within your remote control, it's an infrared device for your TV. Within your TV, there's an IR reader or sensor, which just sees quick flashes of light. What the IR210 does is simulates being a remote control, so you need to teach it certain remote control codes, and it will send the corresponding flash, which will turn on your TV, change the channel. You could also use it to control some lights or some what you call ceiling fans as well. You just simply point the IR blaster towards that device, and it'll act like a remote control.
So basically, it can learn up to 176 different IR commands, and you can program them into the IR210, and then you can program the touch screen, the touchpad controllers to, with a push of a button, you can control your television, projector, or any other kind of infrared type equipment.
Yes, the IR210 is Modbus slave device. So with each Modbus register stored in the IR210, you can associate it with what do you call it, one of the IR signals to perform an action. So for instance, in Modbus Register 1, you'll save the signal to turn on a TV. So every time you send the IR210 that specific request, then it will turn on the TV. And you just store different operations in each of the different registers that Maria mentioned, and then you can perform the different operations by performing a write function to that specific Modbus register.
Okay, and Stefan is asking if we have a tutorial so they can start working with the simple unit like a vanilla flavor where they can add and modify. We do have a quick start guide available. I'll also send you a link to that later after the training.
There's many demo programs. The demo all function and this demo right here are very good, per se, tutorials slash outlines for learning. Because they have devices and functions, you can use that for testing out, seeing what each of the widgets does, and being able to create your own. You'll just simply click on, say for instance, this slider right here. It'll show the properties over here in the inspector, and you'll see just by being able to change the different properties, you'll see what happens on the screen.
Okay, and then Dawn is asking if we have a wireless version or if they need to be hardwired. They do need to be hardwired, and we do have wireless Zigbee type devices and also Wi-Fi wireless equipment that you could use with the touchpads. I'll also send information on that in an email later. So I'll send you an email later today with the slides and also show you where you will be able to watch the video at a later time of this training. Thank you so much for attending the training. Stefan is asking if there's Bluetooth capability. No, there's not for these products, but Zigbee is better for industrial type of applications. It's a bit more robust. I will send you information on that. Thank you and have a great day.
Okay, thank you for attending, and we'll see you next time. Bye-bye.
Bye-bye.